Hello, everyone. This is Dr. White here with the first of a projected 2 screencasts on Chapter 10, and this is about the Tidyverse. It's a different way of doing operations, particularly with data tables, data frames, than what we learned in Chapter 7, and it's in some ways more convenient. And it goes along nicely with the things you learned in Chapter 7 to give you alternatives for how to manipulate data tables. So, first of all, you're going to be introduced to the Tidyverse package. It's not really a package. It's a collection of packages. So when you say library Tidyverse, like you should do if you're following along with these slides, do this in our studio, then it's going to load 6 packages for you. ggplot2, a package tibble that we'll discuss a little bit, tidyr that we won't get to, readr that we won't get to, perr that we won't get to, and dplyr that we will use some of. First of all, let's learn about the pipe operator that comes along with the Tidyverse. The pipe operator is percent bigger than sign percent, okay? And it comes from the mutate package, which is not attached when you library the Tidyverse, but the Tidyverse makes sure that some of the mutate package functions come in, and one of them is this pipe operator. So how do you use it? Well, here's an example. If you were to take hello and pipe it in to a call to rep where times is 4, then you get out hello, 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 hello. And this is very interesting. Why is that happening? Why is this the same as rep quotes hello times equal 4? Well, the idea of the pipe is just this. The value that's returned by the first expression or a call, the thing that's on the left-hand side of the pipe, becomes the first argument of the second call, the thing that's on the right-hand side of the pipe. So back to this example, the value that comes from evaluating quotes hello is just the string hello. And that will become the first argument to the rep function here. And so that's why it's like rep hello times equal 4. In this next example, this expression here evaluates to the M111 survey data frame inside the Beginning Computer Science with R package. That becomes the first and apparently the only argument to the function nrow that is after the pipe. And we know about nrow when it's given a data frame that says how many rows the data frame has, so we get the 71. Now, you can pipe the left-hand side to something other than the first argument of the function on the right-hand side. But you have to tell the pipe operator where it's got to go if you do that. So here's another way of doing rep hello times is 4. We pipe 4 into rep hello as the times argument. The dot there says where that 4 needs to go. If it ain't going into the first argument, then you need to specify a dot to say where it actually goes. So, like, here's another example that at first seems a little bizarre, but when you think about it, you see why it works. Sec 1 to 100 by equals 4. So that evaluates to the sequence of numbers 1, and then 5, and then 9, and then 13, all the way up till you get past 100, and it stops. So that sequence is being piped in here where the dot is. And then after it, we have the square brackets. So what's happening is we're selecting the third item out of that sequence. 1, 5, 9. The third item is 9, and there it is. So why don't we practice with this? We've got a function call here to sec, where we're just creating the numbers from 2 onward, going up by 4 until we reach 22. 2, 6, 10, 14, 18, 22. Let's rewrite that in several different ways using the pipe operator. So I'm just going to head over to RStudio and open up myself a little R script to play around with. And let me library the Tidyverse first. And let me also make the screen a little bit bigger. And let's go ahead and just run the regular old function, getting the 2, 6, 10, 14, and 20, 14, 18, and 22 down the console. Now let's think about how to do that with pipe. We could take 2 and we could pipe it. Now, when you type the pipe, you could do %, bigger than sign, %. You could do that one by one. But guess what? There's a shortcut. There's a keyboard shortcut. I really hope you learn it. It's Control-Shift-M. Or if you're on a Mac, Command-Shift-M. So I'm on my Mac. I hold my fingers down on Command and Shift, and I find the M, and boom, there's a pipe with a stylish space after it. So that's very nice. Command Shift M. Really great. And then I'll do sec, and the second argument, the to argument is still a 22. The by argument is still a 4. Let's see if this works. Yeah, it did. Another way to rewrite it with the pipe would be to pipe in the 22. Sec. Now, the 2 is the first the number 2 is the first argument. It's the from argument. The to argument is the 22, so I say a dot, and then by equals 4. So let's give this a try. It worked again. Once more, let's take 4 and pipe it in to sec, where the from argument is the number 2, the to argument is the number 22, and the by argument is dot. And that worked again. So 3 ways to rewrite with the pipe. Now, I know what you're probably thinking at this point. What good is this funny pipe operator when you just write regular old function calls? We will see. But before we can really see, we need to introduce another nice feature that comes with the Tidyverse tibbles. So what sort of thing is M111 survey anyway? We know it's a data frame. But officially, the sort of thing that a thing is in R is called its class. And there is an R function called class that can be used to find the class of an R object. So the class of M111 survey from BCSCR is quotes data frame. It's a data frame. Now, tibbles are similar to data frames. They're two-dimensional objects, and they have rows and columns, and the rows correspond to an observation, and the columns correspond to variables that you measure on each observation, just like a data frame. They just have a different class. You can turn a regular data frame into a tibble, and I'm going to do that here. I'll try this out in RStudio. So survey here, see, it looks like a data frame over in the global environment. And if I were to click on the little blue button, I get the structure like I'm used to, the regular 12 variables. If I were to click on the name itself, I would get the view looking just like M111 survey. And so you might wonder, like, what's different about it? Let's check on its class by running class of survey. And down in the console, we see that it has three classes: table, df table, and data frame. The class of an object is something that R looks at when it needs to process the object in various ways. And having these extra class names like table, df, and table is what makes a tibble a tibble. Okay, let's see how it might behave in different ways than a data frame. Well, one thing is if you just ask to evaluate it. If you would ask to evaluate M111 survey down in RStudio, let's just give this a try. Say down at the, it's right here, BCSCR M111 survey. And when we run that expression, then what comes out to the console is this printout of that whole data frame, and it's big and it's messy and it slops over because there's so many columns. But what if you just evaluated survey? Then you get something much more manageable. A little description at the beginning, and a sample, just the first 10 rows. And not all the columns, just enough columns that would fit into the available width that you've assigned to the console window in RStudio. And it tells you what the other hidden variables are that didn't make it because there wasn't enough width. So it's a nice compact printout that's much easier to sort of read, and yet you can still get an idea of what you're looking at, even though it's not the whole thing printed out. So let's take the idea of tibble, and let's take the idea of the pipe and put them together to do some data manipulation with some of the functions in the dplyr package that comes along with Tidyverse. First off is the dplyr function called filter, okay? And the first argument to filter is a data table, like a data frame or a tibble, any kind of data table. And the second argument is going to be a Boolean condition. And that Boolean condition is going to be used to pick out just the rows of the data table where that condition is true. And so what we're doing here, survey is getting piped in as the first argument to filter, and we're going to get all the rows where the sex of the person is male and their height is more than 70, or the sex of the person is female and their height is less than 55. So it's like looking for everybody who's either a very tall guy or a very short female. And what dplyr will do is, the result of any of its manipulations is going to be a tibble, even if the thing that came into it was a data table. Now, survey is a tibble, so it's already there. But if I had given it M111 survey, then I still would have gotten this nice tibble out. Now, the filter command probably reminded you of the subset function from chapter 7 for picking out rows in a data frame. And you might wonder, well, how do I pick out columns? The subset function had a select parameter that you could use to get the columns. Well, dplyr has its own function called select. And when you give it, as its first argument, a data table, the subsequent arguments are interpreted to be the names of the columns that you want to select out. So survey is being piped in here as the first argument to select, and I'm looking for the sex, height, and fastest column. So let's give this a try over in RStudio because we want to follow along. Practice. Okay, run it. And sure enough, out in the console, comes just those 3 columns in that compact tibble printout form. Now you may still be wondering, why the pipe? Why the pipe? You know, well, the reason is that what gets returned by these dplyr functions like filter and select is actually another data table. So they take a data table as their first argument, and then they return a data table as well. And so with the pipe, you can actually chain these functions together, compose them together in a very nice, readable way. Watch an example of this. Survey is getting piped in as the first argument to the filter here, where we're looking for all of the tall guys or short gals. But then see the pipe over here? The resulting data frame with just the tall guys and the short gals, but all the columns, is being piped into select as the first argument. And we're pulling out sex, height, and fastest. And so the result is a data frame that only has 22 rows because there were only 22 tall males or short females, and just those 3 columns that were asked for. This one's a good one to copy paste and try out in RStudio. We kind of isolate it. And what I'm going to do to kind of better understand how this thing is working is I'm going to run survey piped up through the filter, but stop before the second pipe and just run that little selection. And we get the tibble out 22 rows because there's only 22 tall males or short females, but all 12 columns. Now I'll run the whole thing. And so the data table that we see in the console is getting fed into the select function now, and we get the result. So this is your first example of chaining. That's multiple multiple uses of the pipe operator to one dplyr function after another. And it makes it kind of easy to see what is going on, even if you don't really know the R code. An ordinary reader can come and say, well, this data table, first we're grabbing some rows, then we're selecting some columns. If you want to leave some columns out, you can do that with select. You just put minus signs in front of the columns you want to leave out. So here's an example where we're just knocking out the ideal height and the love first column from survey. Another useful dplyr function is mutate. This is a quick and easy way to create new columns out of old columns. Here, survey is being passed in as the first argument of mutate. Like the other data functions we've seen, the filter and the select, mutate takes a data table as its first argument and returns a data table. Now the second argument, though, starts off with what is going to be the name of the new column, then an equal sign, and then afterwards some kind of expression involving some of the columns of the data frame. So here, this is a Boolean expression. Fastest, remember the fastest variable, fastest you ever drove a car, bigger than 125. So that's going to be trues and falses. And then I'm piping in the resulting extended data table that has this extra column called Daredevil into the select, and I'm only picking out the sex, fastest, and Daredevil columns. And sure enough, you can see that new Daredevil column here. Totally okay to create multiple new variables with one call to mutate. So here, survey is getting passed in this first argument of mutate, and there's two more arguments. This one, then the telltale comma, and then this other argument. The first argument creates the daredevil variable like before. The second one takes the fastest speed in miles per hour and multiplies by a number that turns it into kilometers per hour. And then that data table is getting piped in to be the first argument to ggplot. ggplot's first argument is the data frame that you're going to use to get the variables to make the plot out of. And so we're going to be making a plot where, oh, look at this. It's going to be box plots. And I guess it's going to be a pair of them. One for where Daredevil is false and another where Daredevil is true. And what are we making box plots of? The GPAs of the people who are not Daredevils, they didn't drive so fast, and the people who are Daredevils, who drove faster than 125. So let's give this a little try over here in the console or studio. So first of all, we're just going to run these lines down through the mutate. And sure enough, we get this data frame that has the two extra columns, Daredevil and speed in kilometers per hour. And now let's go ahead and run it all. And now the result is this plot that we see in the window. And so there were only a few people who drove faster than 125 miles per hour. Their GPAs aren't that bad, though, compared to the many people who drove slow. So again, this pipe operator allows this chaining process to happen, and it makes it easier to read and understand how the code is working. Here's two more cool dplyr functions. One is group by, and the other is summarize, and they are often used together. They're kind of like the drummer and the bass guitar player in a rock and roll band. They work together to create kind of an underlying rhythm for the whole band. Group by and summarize work great together. Remember that CPS 85 data that comes from the package mosaic data. I'm just going to run this little command here to read it into my R session's memory. So here it comes CPS 85 in on a promise. And what I'd like to do is get the mean wage for each sex. You may remember back in Chapter 8, one of the homework problems was to make violin plots of the wages for the males and the females. And when you look at the plots, it seemed like maybe males tended to make a higher wage on average, but it was a little hard to tell, and you certainly couldn't tell how much higher. But now we're going to figure out how much higher. CPS gets piped in as the first argument to group by. The second argument is sex. What's the effect of this? Let's just take this, copy, and go to our studio again. And I'm just going to run up through the group by. And so when you look at this, it doesn't look any different than the CPS 85 table itself. But behind the scenes, R has attached some information to this data table saying we have two groups. All the rows where the sex is M for male, and all the rows where the sex is F for female. And so with that knowledge, that new table with that extra information is piped in as the first argument to the summarize function here. And what do we want to summarize? Well, we want to take the mean of the wages, the wage variable, it's present here in this data frame right here. We're going to take the mean wage for each group, for all the males, for all the females. And let's see what comes out. So I'm going to run the whole thing now. And so we get that little table that we saw in the slides. So when you do a group by and then a summarize, the only rows are going to be the different possible values for what you group by, so male and female. And the only columns are going to be what emerges from your summary, the mean wage. All the other columns get kicked out. So it's a tiny, tiny, tiny little data table that comes out. It's totally okay to do more than one summary within your summarize command. So in this version, we're again computing the mean of the wages, but we also are going to ask for a new column in that reports how many rows were in each of the groups. And the way you count up the number of rows is with a dplyr function called in. And so you call that function so it's in with parentheses. It doesn't need any arguments. It just counts the rows in each group. So if you were to run this in RStudio, you would get this out of the console. And so what we find is of the 245 females in the study, they made an average of $7.88 an hour back in 1985. And of the 289 males in the study, well, they averaged almost $10 an hour. And so the guys were making, what's this, $2.11 more per hour on average than the gals were. So there's a wage gap there. Here's another example of just sort of dplyr kung fu. Take CPS 85 and pipe it in to be the dot here, $wage. So what we're doing is just asking to get the wage variable out of the CPS 85 data frame. Pipe that into a function called 5num. Well, what's 5num? Hey, let's ask. So I go down to RStudio and ask for 5num, and I get some help here, which I'll pop up big. Returns Tukey's 5-number summary. The minimum, the lower hinge, that's the 25th percentile, the median, the upper hinge, the maximum for the input data. Okay. And so what we've got here is the minimum wage made by anybody was $1 an hour. The 25th percentile is $5.25 an hour. Here's the median wage, $7.78, 75th percentile, and then the maximum wage, that one person that made the really high wage of $44.50 an hour. Now, I introduced you to 5num to show you how you could make a really fancy summary if you wanted for the females and the males. Take CPS 85, group by sex again, and now summarize. And what we want to know is how many males and females there were. So we call the in function, and we call the result in. And we want to know the minimum of the wages. Well, that would be the 5num of wage, that first element of it. We want to know the first quartile. Well, that would be the second element. The median is the third quartile, and the max similarly. And so if we were to run all of these things, we would get this very nice summary. And it's another way you can compare the medians, another way to see that guys are making more than gals on average back in 1985. You can group by more than one variable. So let's look at this. and I'll just go ahead and copy paste and try this one in RStudio. Go to my notes. And let me just run CPS85 group by sector and sex. And again, it looks exactly like CPS85, but some information has been attached to it on the side. The people have been broken down by the sector of employment. There were 8 sectors, you may remember. And then within each sector, they've been broken down into males and females. So that would actually be as many as 16 different groups. 8 times 2 is 16 that have been created by that group bot. So the summarize now that is being done, all these things, row numbers up through the different parts of 5 number, they are being computed on each of the resulting groups. And so if we run the whole thing, then we get a bigger summary table here. And there's a total of 15 groups, only 15 because it turns out that there were no female construction workers in the data set, so the const only had an M group inside of it. But you can use this to see, what happens within each sector of employment, who's making more on average. Like we could look at the medians, and we could see that for clerical workers, guys really don't make that much more, 69 cents more. Can't do anything with construction because there's no females. For managers, female managers making $10 an hour on average, and guys making $14 an hour on average. That's a big gap. And if you follow through some of the remaining ones, you see that usually there's a big gap, and it's in favor of the guys. So the wage gap that we saw overall for the two sexes, it can't be due to women choosing to work in lower paying sectors of employment like clerical or service, because even when you look at males and females in the same sector, the guys are making more. If you would like your summaries or other output of your data manipulations to be saved somewhere rather than just be spit out to the console and lost, then of course you could just use the assignment operator. So here I'm binding the name sex sector to the results of that same summary that we just did. Give it a try up here in notes. So there's sex sector, 15 observations of 8 variables. And so it's a data table, it's a tibble. It does have a slightly extra bit more in terms of its class. So if we ask for the class of sex sector, in addition to the table df and the table that make it into a tibble, it's a grouped df that comes from the grouping operation that was done up here. That information is still riding alongside of the table. If you're interested in working with R Markdown, then you want to think about how to print tables out in an R Markdown document. You've already got some screencasts that address this issue, but I just want to quickly review it here. In our Markdown documents, very small tables, like the ones that just was like the mean wage of the males and females, you could just print it like it is. You could just evaluate the name of the table and let it go out. But for anything much bigger, say 3 to 15 rows, I really suggest that you do knitr cable on it. So you put the name of your data table that you've got inside the parentheses here, and that'll print up kind of nice. Larger tables, you should use DT data table with. So an example of a very small table, as I said, would be this one that just compared the mean wages for males and females. Totally fine to just have that spit out into the output of the console or the output of your markdown document. Medium-sized table, like that one about when you're grouping, say, by sector and comparing the wages of people across sectors, grouping by sector and then getting the mean wage here and the number of people in each sector. Once you've produced that, just pipe that in as the first argument to knitr cable. The second argument, by the way, is caption, and you can give your table a nice caption in rmarkdown. And so it would not necessarily like, it would, its exact appearance would be different for different rmarkdown documents, but for the kinds of rmarkdown slides that I'm making here, that's how a cable looks. For large tables, so here what we're doing is grouping by sector and taking the top 10 wage getters within each sector. And then we're arranging the results by sector in decreasing order of the wage. That's what the minus sign does here. That data table is going to get piped into DT data table. Now I'm just going to make the data table down here in my RStudio so you can get a look at it. And so you can see we've arranged by sector, and so clerical is going to come first because it comes first in the alphabet for the 8 sectors. Tibbles show 10 rows, so we actually are looking at the top 10 wage getters amongst clerical workers. The top wage getter got $15 an hour. The 10th highest got $11.20. There would be 10 more for each of the 7 other sectors in this data set. Now, actually, it's a total apparently of 81, and I think that's probably because 2 people tied for the same wage at some point in among the top 10, and so we actually had 11 in one of the groups. Wonder which one it was. So if you wanted to actually find out, head back to the slides, because in an rmarkdown document, you can take that table and pipe it in as the first and only argument to DT data table, and you get this result out. And then if you wanted, you could, plow through and look for, like, who are those 2 people that tied? It's kind of nice. So let's see if there's anything more. I guess there's a tiny bit more. Just a little bit more about DT data table. Again, the screencasts address this somewhat and give you a link to the web page where you can learn more about data table options. But you can control like how many rows are going to show up in your data table, and you can control what kind of menu is going to be given to the user to determine for themselves how many rows they would like to see show up on each little page of the data table. That's kind of neat. And so applying that, we got a little bit shorter, easier to look at data table, and the menu here is one that we determine for ourselves. Another nice one is if there's a lot of variables in your data table, if you say scrollx is true in your options, then you get a nice horizontal scroll bar. So like M111 survey has 12 variables, which is way too many to fit into the width provided for these slides, but this data table gives me a little scroll bar and 5. So that's all for now. There will be another screencast giving you some more practice with dplyr work and with ggplot2, with the pipe operator always playing a starring role.